Again, projectile could be you hitting a golf ball, and the golf ball will travel like this. Notice we have movement in two dimension. We are moving from here to there, so you move in the x direction, and the ball also went upward, then down. So you have movement in both dimensions, in the x direction and in the y direction. That's why it's called two-dimensional kinematics. Or a car goes off a cliff. There's the car here. Goes off the cliff, and it lands right here. That's a motion in two dimension. The car traveled in that direction, that's the x direction, also went down, which is what? The y direction. So when we start talking about two-dimensional motion or projectile motion, there are some basic equations we need to look at it. One thing you're going to learn quickly about projectile motion, that your velocity in the x direction is constant. So the velocity in the x direction is constant. What does that mean, the velocity in the x direction is constant? That means your initial velocity is going to equal your final velocity is going to equal to your average velocity. I'm writing x for velocity. Why am I writing x? Your initial velocity, your final velocity, your average velocity, all are the same. We'll just call that v. They're the same. They don't change. And by the way, if your velocity is constant, it doesn't change. What is your acceleration then? What is it? In the x direction. I'm just talking about the x direction. Somebody said it. What was it? 0. Why? Because acceleration is final velocity minus the initial velocity divided by the time. Well, if your velocity is the same, the result is 0. You have no acceleration in the x direction. I'm just talking about the x direction. So let me put big writing x direction here. That's all I'm talking about. Your velocity in the x direction is constant. Your acceleration is 0. Which means, remember the four equations that we had? Let's look at the basic equations. We had x equals x sub 0 plus vt. V average. Well, in the x direction, since the average is the same, I'm talking about the x direction, I'm not going to say v average, I'm going to say v. And if my x sub 0 is always, we measure that as 0, it really says x equals v times t. That's one equation in the x direction. Let's look at the other equations. We have another equation that says what? X equals x sub 0 plus v0 times t plus 1/2 at squared. Again, I'm talking about x direction only. What is your acceleration in the x direction? We just said the acceleration is what? 0. So what's going to happen? This equation becomes x sub 0 plus, since the velocity is constant, and this is always a 0, well, that third or fourth equation is the same as the first equation. What was the last equation we looked at? It says v final squared equals v initial squared plus 2a times x minus x sub 0, right? Well, if a is 0, that tells you what? Your final velocity squared equals the initial velocity squared. Well, we know that. which means V final equals V initial. Well, we know that in the x direction. So all these basic equations that we have in physics, they shrink to one single equation when we talk about the x direction. And that is, this is the only equation we have in the x direction. X equals velocity in the x direction times t. That's the only equation in the x direction that we have. The other ones, they disappear. They become that equation or v equals to v0 and nothing else. In the y directions, all of them are good. We still have every one of them. So in the y direction, the equations are good. The first one was what? V equals V0 plus AT, except in the y direction, what do we call the acceleration? G. X, well, we didn't call it x in the y direction, we called what? Y, right? Y equals y sub 0 plus V average times t. That's still good. Or y equals y sub 0, we said the V average is what? 1/2 V final plus V initial times t. Equation 1, equation 2, equation 3. What was equation 4? Y equals y sub 0 plus V0t plus 1/2 what? GT squared. And what was equation number 5? V final squared equals what? V initial squared plus 2 times the acceleration, which is what? G times y minus y sub 0. If you don't like to write y minus y sub 0, you can make that what? Times delta y. So all 5 equations are still good and valid in the y direction. So let's take an example here and see what happens. Maybe I can use clean paper here. Save the graphing paper. Let's go back to that car getting off the cliff. I'm working for a crime scene investigator. We have a car crash here. A car went off the cliff straight down. We know the height of the cliff, I don't know, it's 10 meters. The height of it. It's horizontal. The car was actually going straight in this direction, horizontally, 0 angle. So it has an initial velocity which is unknown. I'm trying to find out, my job to see if that driver was speeding or not. So I show up at the scene here, I go, uh-oh, that's 10 meter high. Where's the car? The car is down there. So when the car went off the cliff, it went like this. So down here, there's the car, messed up there. It's all mangled. The tires and everything. The car is a mess there. I measure the distance where the car landed And I notice that's 25 meters. I know the height is 10 meters here. My job is to figure out if the car was speeding or not. Now, one thing about projectile, if you took that car and dropped it straight down, it will take the same time as if you went off this at 100 miles per hour. The time in the air will be the same. So if I take my pen, roll it off this table, and at the same time, when this one leaves, I drop another one, they both should hit the ground at the same time. I'm not really very, I don't know the word I'm using here, not talent. Multitasking, that's the word. I can't like watch them and drop them at the same time. But if you release them at the same time, you will hear them hit the ground at the same time. You know, they have to. If you neglect the wind resistance, they have to hit the ground at the same time. No if, no buts, nothing. So the time for the car to drop straight down or goes like this will be the same thing. Just like if somebody fire a bullet from this here, you know the bullet's going really fast, it's going to go way far and drop. Will take the same time as if you drop the chalk straight down. Time-wise, it's the same thing because the height is the same. So can we calculate how fast the car was moving? So I'm going to take this problem, break it down to two separate problems. My job to get the initial velocity. Let's write here the x direction. And let's write here the y direction. In the x direction, what is the initial velocity of the car? In the x direction. How fast was the car going in the x direction? Can't be zero. If it's zero, the car will never go off the cliff, right? Yeah, but we're not sure what that number is. Unknown. Well, I'm looking for it. In the x direction, the car was going horizontally. What else we know about the x direction? This is the height. That's the y direction. Do we know how far the car traveled in the x direction?
Yes.
How far? 25 meters. Remember, there's only one equation in the x direction. What's that equation? X equals the velocity or the initial velocity times the time. The velocity is constant. I know my distance. My distance is what? 25. I'm looking for the initial velocity. Do I know what the time is? No. But if I can find the time, can I solve for the initial velocity? Okay, let's look at the y direction. Let me use the ground as reference for height here. What do we know about the car? What was the initial velocity in the y direction? In the y direction.
No, that's.
I'm looking for the speed. How fast the car was going up and down in the y direction? 0 when it went off the cliff. It wasn't going up and down. There was no angle to that road. Once the car leaves that road and it's in the air, what's pulling on it? Gravity. So the acceleration equals gravity. And I'm using down as negative. What else do we know? What was the initial height of the car? 10 meters. What was the final height of the car? Can we find the time? Because if I can find the time, I can plug it in here and get my initial velocity. Remember, all the equations that we covered are available in the y direction. So look through your notes, see which one maybe will give me that. Could I use this one, y equals y sub 0 plus V0t plus 1/2 gt squared. Could I use that one? Y is 0. What was y sub 0? 10 plus 0. This will be a negative 1/2 times negative 9.8. That's 4.9 t squared. I took the 1/2, I multiplied it by the negative 9.8. So 4.9 t squared equals what? 10? Can we get what t squared is? 10 divided by 4.9, 2.04, which means t will be the square root of that number, 1.43. And once you have that time, come back with it to this equation now and plug it in. Can we get with the initial velocity of the car? 25 divided by that number, which is 17.5 meters per second. And if you want to convert that to miles per hour times 2.24, I think, the car was going 39.2 miles per hour. So it depends on that spot. What was the speed limit posted there? Was it 25? If it is, yep, he was speeding. If the speed limit was 40, was he speeding? No. So with two measurements, again, the height and where it landed, we can pinpoint how fast the driver was going.
Can't you just use the equation 2 times height divided by gravity and square root it?
Well, that's the result of all the stuff there. Without
You
really,
have to do all that.
yeah, but you don't understand. Like when you use these equations, a lot of times you have no idea why we use them, how they work, you know. And if this angle is not horizontal, that doesn't work, that equation. So that's why I'm not a big fan of just grabbing an equation and using it. It does make the math easier, but really there's no understanding to the process there. Where this, you get to see it. Now, if I put it on an angle, my process is not going to change. That equation you mentioned, you can't use it now. But it does give you the same answer. Yep, in like 5 steps or even less. But that's the result of doing this and this all together. And again, if it's not horizontal, you can't use them. So keep that in mind, that equation. Let's take another one. This time we'll do the same thing, horizontal. And we have Houston last week. We had massive flooding there. So there are some people stranded there. We're trying to ship to them some supplies there. There's the water there. And there's people there. There's homes and people on the roof looking for help. Covered with water. So the helicopter comes around here at 1,000 feet high. Here's my helicopter. Let's say it's 1,000 foot high. And it's moving at a speed of, I don't know. Actually, I'll do. How fast the helicopter goes? 120 miles per hour. And they want to drop a package, water and food supply for those people stranded. You want to make sure actually that that package does not land here or land there. You want it to land right there so they can get it. I don't want them to jump in the water. And the question is, where should I drop it? How far? What's that distance? So they will get it. Because I need to know the helicopter, when I reach that point, drop the package. the package is going to travel, it's going to be right next to the house. If it's not on top of the house, very close to them, they can swim to it, grab it, and drag it back. So I try to give you units intentionally. They're not in the right units there, so you can change them. So this is miles per hour. I have to change it to meters per second. So here we go, 120 miles per hour over 1. I'm going to go from miles per hour to meters per second. 1 meter per second is at 2.24 miles per hour. Check that conversion factor, make sure the correct units. It's 53.57 meters per second. The height, it's 1,000 foot. Let's convert that to meters. You want feet on the bottom, meters on the top. 1 meter is what, 3.281, is it? Double check that number too. Anyone has their sheet with them? I want to make sure before we continue we don't put the wrong one.
Yeah, it's 3.281 feet.
And the mile is 2.24. So that plane was 1,000 divided by 3.281, which is 304.79 meters. I can make my life easy and make that roughly 54 meters per second, and I make that what, 305? That's good enough. If you're off by a hair, they can get it. Throw a rope to it and pull on it. I just don't want to throw it a mile from them or half a mile from them. But if it's like 2 feet off to the left or to the right, they can get it. Again, it's a projectile. The helicopter was flying horizontally. Again, I'm doing the same example. In a few minutes, I'll change it. So here's the x direction. And there's the y direction. In the x direction, we know the initial velocity in the x direction, which is what? 54. And there's only one equation in the x direction. X equals the initial velocity times time, which is 54 times t. And I don't know what t is. I need to get that. In the y direction, the initial velocity is 0 in the y direction. The plane was going horizontally. If I use the water level here as reference, the initial height is what? 305. The final height is 0. It's going to hit next to the house. Otherwise, I got to calculate how high the house above the water. I know the acceleration equals gravity, which is negative 9.8. And I'm looking for the time. The same equation, I bet you. Y equals y sub 0 plus v0t plus 1/2 gt squared. Y sub 0 is 305 plus v0 times t, that's 0. This will be negative 4.9 t squared. 4.9 t squared equals 305. T squared equals what? 305 divided by 4.9. 62.24. T is the square root of that. And it's 7.9 seconds. Now take that number and plug it in here. $7.9 times 54 is 426 meters away. So roughly, how many feet that is? Times 3.281. When the helicopter is approximately 1,000 or 1,400 feet, it's 1,398. So when the helicopter is 1,400 feet away, you want to drop that package. So somebody got to do the calculation, tell the pilot, when you're approximately 1,400 feet away from that spot there, you release that package, you drop it, it should land right next to the house or on the house. Okay, both examples I made, they were nice because it was horizontal. What happens when it's not horizontal? Like a golf ball, a basketball, a baseball player. If you ever watch baseball, don't watch the Red Sox, they're horrible this year. But when they throw the ball, shortstop to first baseman, you always see the ball goes up in the air, it comes back to him, because if you throw it horizontally, unless you have a can for an arm, that ball is going to go down, 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 it's going to hit the ground before it gets to first base. So you put that little arch on it to reach that. So let's take an example. Or if you watch somebody dive actually from a diving board, they jump off the diving board. They have initial velocity, usually on angle like this. They go forward and up there. So maybe we'll do that. Somebody's standing on a diving board here. I'll do the baseball after that. And they jump in this direction with initial speed, because they want to go like this when they dive. Notice, because they hit that board, they bounce upward, they go forward, they have initial velocity in the y direction. If their speed was in this direction, not upward, I'm giving it to you in that direction, of 10 meters per second, that's really fast, at an angle of 30 degrees. Let's ask a few questions. The first question, let me give you the height of the diving board. The diving board is, what's a standard diving board, a good one?
30 feet.
30 feet. So let's convert that to meters already. What's that, 10 meters? How's that? Make life easy. 32 feet, 10 meters. The first question, what's the maximum height? How high that person is going to reach? What is that height? Find the maximum height. Question number 1. Question number 2. How far from the diving board, from where they jump, where they're going to land? X. Find the distance X. And question number 3. Find the velocity when they enter the ground, when they enter the water. Enter in the ground, you're in trouble. when the diver enters the water? When he or she, instead of the diver, I want to say, but I left the word diver out. When also I go he/she enters the water. Was the ask for the velocity, not the speed. That means you have to give me value and direction. Let's write what we know. X direction, Y direction. I have a lot of questions here I'm asking. I'll answer them all. The X direction. And the Y direction. What was the initial velocity in the X direction? I'll give you a little hint before you answer. It's not 10. If it was 0, you won't go forward, right? You'll straight down. The fact you went farther, that tells me it's not 0. We did that in chapter 3. You are given R and you are given theta. You need to find the X and the Y component.
R cosine theta.
The initial velocity is 10 cosine 30 degrees, correct. That's the X component of your velocity. This is the velocity in that direction. So what's the velocity in the X direction? That's the X component. 10 cosine 30, I think that's 8.6, I think. 8.7 or 8.66, I think. 10 cosine 30, 8.66, 8.7 meters per second. What is the initial velocity in the Y direction? And it's not 0 either because you went higher than the diving board.
Is it sine of?
Yep.
Sine of 30?
10 times the sine of the 30. And that's a 5. That's the only thing we know in the X direction. We don't know what the time is. One of the questions to find X, I can give you X if you tell me what the time is. X equals what? V0 times t, isn't it? So X equals, what's V0? 8.6 multiplied by the time. If I know what the time is, I'm done. In the Y direction, what do we know? We know that the initial height, if I use the water's reference here, was what? 10 meters. We know the final height, which is what? 0. We know the acceleration, which is gravity, and that's negative 9.8. And I'm looking for the time. Same equation, I think, right? Notice that equation that you mentioned earlier, you can't use it now. Y is 0, y sub 0 is 10. This is 5 times t. This is negative 4.9 t squared. We have a quadratic equation. 4.9 t squared minus 5t minus the 10 equals to 0. I decide I'm going to divide everything by -1 to make that a positive. And to solve this, I got to use the quadratic formula. So t equals minus b plus or minus the square root of what? B squared minus 4ac divided by 2a. That's a 5. Minus a minus, that's a plus. Take a negative 5 squared, that's 25. Minus 4 times a times c, that becomes actually a plus because that's a negative here. 40 times 4.9, 196 divided by 9.8. This is 221. Take the square root of that. It's 5 plus or minus, what is it, 196 plus 25, 221, what's the square, oh, clear. What is the square root of 221? 14.9. Since time will never be negative, I have to use the plus only. So it's 5 plus that number. Can't be negative. .03. So we know the diver was in the air for 2.03 seconds. Now, if you bring that value and plug it back in here, how far from the diving board where he enters or she enters the water? 8.6 times 2.03, roughly 17.5 meters. So that's one of the questions we answered. We got 2 more questions on that. One of them is, what is the maximum height it will reach, or the diver will reach? Let's look at that picture. I left it sitting here. That maximum height. This is your maximum height. What is that h? When you reach that, what is your final velocity here? In the y direction. What is the final velocity in the y direction here? It better be 0. Because if you had any more velocity, what will happen? Keep on going. So let's look at that for maximum height. That's the first question we asked. For maximum height. Let's write what we know. In the y direction, we know the initial velocity in the y direction, so I'm just writing about the y direction here. The initial velocity was 5. Remember that? Right here. Positive 5, because you were going upward. We know the initial height, initial velocity, not height here. The initial velocity was 5. What was the initial height? Where was the diver in reference to the water? How high? 10 meters. For maximum height, what's the final height? It's not 0. What is that distance from here to there?
17.5.
How do we know 17.5? That's h, right? Unknown. I'm looking for it. What else we know? I know my final velocity when I reach the top is what? 0. And I know the acceleration, which is what? Gravity, and that's what? Negative 9.8. Do we have an equation we can use that has all these pieces in it? How about 5? How about that equation? V squared, final velocity, which is what? 0 squared, that's still 0. Initial velocity, 5 squared, that's still 25. Two times negative 9.8 times what? Y, which is, what's y? H minus, what's y sub 0? Is that 10? So that's minus 19.6 times h minus 10. Now distribute that one. 0 equals 25 minus 19.6h plus 196. 221 minus 19.6h. Bring the 19.6h to this side, becomes a plus. What is h equal to? 221 divided by 19.6, which is 11.3 meters. So the diving board was actually 10 meter high. So when he hit it, the diver hit it, the maximum height above that was 1.3 meters. So went above this much above the diving board. Then back into the water. The last part of this question. What was the velocity of the diver when he enters or she enters the water? The velocity when he/she enters the water. So if this is my water, here's a diver again, the one like this. Remember, we said the velocity in the x direction never changes. The entire flight, the velocity in the x direction stayed the same. That number stayed the same. But the velocity in the y direction, it was like this. Start to decrease till it hits 0. Then start to pick up down there, increase. That's what's going to happen during the flight. So the velocity in the y direction is positive, but start to shrink till you hit the maximum height. Now it's 0. Now your reverses start to go negative. Small, bigger. So I need to know what that velocity in the y direction. I know what that number. We calculated that early. We said the velocity in the x direction for that was what? 8.6. That never changed. So if I know what the velocity here in the y direction, what the found velocity is, I got the x and the y component, I can tell you what the found velocity of the diver when he enters the water, or she enters the water. So again, I'm interested in the velocity in the y direction. I'm only paying attention to the y direction. We know the initial velocity was plus 5. We know the initial height was 10 meters. When the diver hits the water, the final height is 0 meters. We know the acceleration, which is gravity, that's negative 9.8. And now I'm looking for final velocity in the y direction. And the equation, probably the fifth equation. V squared equals V0, which is 25. 5 squared is 25. 2 times negative 9.8 times y, which is 0 minus a 10. (98) times 2 is 196. It's going to be plus or minus, but because we're coming down, the mass is plus or minus. But because we're traveling down, it has to be what? It has to be a negative. So the velocity is really negative 14.9. That's in the y direction. So what is your velocity when you enter the water? The velocity has a value in the x direction of 8.6 in the x direction. Notice that. Also has a value in the y direction, 14.9 in the y direction. That's the velocity in the x direction, that's the velocity in the y direction. If they want what is the speed or the magnitude of that, then we're going to find r and theta. If they ask you for the angle and the magnitude, you know the x and the y component. Let's find the magnitude and theta. So to find r, it's going to be the square root of the x value squared and the y value squared. Square root of 295. When I write these numbers, I round them up, but on my calculator I carry all the digits usually, so sometimes my answers don't exactly match yours because I'm carrying all the digits. And notice again, x is positive, y is negative. Which quadrant? X is positive, y is negative. To the right and down. Quadrant, what? 4. So if you want to find theta, there is no addition here. The inverse tangent of the y value, which is negative 14.9, over the x value, which is 8.6. Negative 60 degrees. Yes?
In the part where you found the velocity entering the water,
Yes.
what did you do with the 0 minus 10.
0 minus 10.
It's upper.
Oh, that's a negative 10. Yep. 0 minus 10 is that negative 10?
Yeah.
Times the negative 98. I mean 9.8. That's a positive 98 times the 2. That's the 196.
Okay. All right.
Yep.
I have a question.
Yes.
In the y direction, we can use any of the five
Correct. They're all good.
problems, right?
Yep.
Okay.
In the x direction, there's only one equation. X equals v0 times t, or x equals v times t. The velocity is the same anyway.
Can you do it out with the first one, v equals vo plus gt?
V equals VO, the
Plus
initial
GT.
velocity. If you know the time. Since we found the time in the previous one, absolutely, yep.
Okay.
So notice the question, could I calculate actually the final velocity here using, could I find the final velocity in the y direction using V equals V0 plus GT? And I said the answer is yes. V0 was what, 5? Gravity is negative 9.8. And from the first part, we calculated the time. Where's my paper? It's about 4-page problem. What was the time for that person in the air?
2.03.
2.03, right? So if you do the math, 5 minus 9.8 times 2.03, which is negative 14.9 meters per second. That's the velocity in the y direction. Is that what we got before? Yep. What was it?
What was negative 14.9?
14.9, yep, in the y direction. So now you're still going to say, well, in the x direction, that velocity never changes, so I still got to find it. So you can use any of these equations. Yep. The only thing I didn't mention here, I'm going to call it quit shortly, is like when you're hitting a ball, especially in golf, is your goal is you want to get the maximum distance traveled, you know? So to get maximum distance, for maximum distance, x here, guess what angle you want to hit it at? There's only one angle that'll give you the maximum distance. 45-degree angle. If you want the ball to go as far as possible, you want to hit it at 45-degree angle. What will happen if this is the 45-degree angle? Let's say this is the 45. We'll go like this. If this is the 45-degree angle. If you hit it at a steeper angle, more than 45, like a 60, the ball will go like this. It doesn't go as far. If you hit it at a smaller angle, it goes like this. It dies before that. So if you see a problem, as you start doing the homework, and it says, we like to reach the maximum distance, that's a hint they're telling you the angle is 45-degree angle. And when you hit a ball, if the ground is level, with initial speed, let's say 50 in this direction, 50 meters per second, if you neglect the wind resistance, when the ball comes back in this direction, guess what the speed is? If it's the same height, it better be 50. And guess what that angle is? It better be that angle, if it's the same height. So if the ground is level, and you're playing golf again, or soccer, you kick the soccer ball at a certain angle, the ball is going to come down, hit the ground at the same angle, with the same speed, if you neglect the wind. Soccer ball is big, so you can't really neglect the wind. Golf ball is small and heavier, so you can pretend the wind is not a factor there. You know. Okay.